Welcome back, friends. We are continuing with our topic of electrochemistry. In the previous topic, I confused some of the few concepts, so I would like to review them first before I am moving further. We discussed the concept of conductivity, conductance, and the ratio of length and area of the electrolytic cell. Na tukasema kwamba when measuring electrolytic conductivity, the observation showed that the conductance of solution varies with change in concentration. That means conductance is inversely proportional to concentration. So we defined molar conductivity, na tukasema molar conductivity ni conductance, molar conductivity ni conductance ya 1m solution, na tukasema is equal to K divided by C. Molar conductivity is equal to K divided by C. Lakini tukasema but 1 divided by concentration is known as dilution, yani V. That is to say molar conductivity is equal to KV. Kwa hiyo nilichokuja kurekebisha hapa ni kwamba hii inaitwa molar conductivity. Hivyo molar conductivity inaitwa molar conductivity, sio molar conductance, ni molar conductivity. So molar conductivity is defined the conductance of a solution containing 1 mole of electrolyte. Conductance of solution containing 1 mole of electrolyte. Molar conductivity is the ratio of electrolytic conductivity K to the molar concentration C. Ratio of electrolytic conductivity K to the molar concentration C equal kwenye gram per mole. So generally molar conductivity is the conductance of that volume solution containing 1 mole of electrolyte, Again, from there, here we had a concept of equivalent conductance, ambayo equivalent conductance tunadefine kama ni power. It defined the conducting power of all ions produced by dissolving 1 gram equivalent of electrolyte in solution. Equivalent conductance inakuwa ni a conducting power of all ions produced by dissolving 1 gram equivalent of electrolyte in the solution. The gram equivalent is the quantity of a substance whose mass in gram is the same as the chemical equivalent. Quantity of substance whose mass in gram is the same as its chemical equivalent, whereby equivalent weight is the atomic or molecular mass of an element or compound per its valence. Kwa hiyo kwa mfano, for elements, let's say calcium, element kama calcium. So calcium, we know the mass of calcium is 40. Kwa hiyo the chemical equivalent of calcium itakuwa 40 divided by charge ya calcium ni 2, itakuwa ni 20. Kwa hiyo tunapozungumzia gram equivalent of calcium, hii maana yake ni sawa na 20 gram. Gram equivalent of calcium ni 20 gram. Sababu tumesema the gram equivalent is the quantity of substance whose mass in gram is the same as its chemical equivalent weight. Mass in gram is the same as the chemical equivalent weight. As the equivalent weight in 20 in the equivalent weight. Ambayo equivalent weight tunachukua mass AR divided by charge. Mass divided by charge tunapata equivalent weight. Kwa hiyo tunaposema a gram equivalent maana yake ni mass ya substance ambayo itakuwa ni sawa na chemical equivalent of a substance. Kwa hiyo the conductance of a solution containing 20 grams of calcium ions, the conductance of calcium ion solution containing 20 grams of calcium ions is what we call the equivalent conductance of the solution. So the equivalent conductance is denoted by a conductance EQ. It is equal to the product of conductivity and specific conductance and the volume. Product of conductivity and the volume in cm cube containing 1 gram of equivalent of electrolyte at the dilution V. Kwa manake equivalent conductance hiyo hapo, conductance equivalent ni sawa na product ya K, specific conductance K, pamoja na volume containing 1 mole ya dilution V, equivalent ya conductance. Unaweza kuona ni kama formula zinafanana na molar conductivity, lakini they are two different things. Now let's discuss the dependence of molar conductivity on concentration. How the molar conductivity of a solution varies with the solution. The molar and the specific conductance of a solution depends on kwanza ionic concentration, pili speed of ions concerned. Ionic concentration and speed of ions concerned. The conductivity of a solution of water is highly dependent on its concentration. The conductivity of solution of water is highly dependent on its concentration. Of the dissolved salt, and sometimes other chemical species which tend to ionize in the solution. So molar conductivity of an electrolyte increases with dilution. Molar conductivity increases with dilution. As we said, molar conductivity is equal to K, then V, where V is dilution. So tunavyoifanya solution become more dilute, then inakuwa na uwezo mkubwa conducting electricity kuliko solution ambayo iko concentrated. Molar conductivity of electrolyte increases with dilution. The variation is different with a strong and weak electrolyte. Starting our discussion with the strong electrolyte. The strong electrolytes are substances which only exist as ions in solution, since they are completely dissociated to the ions when dissolved in solution. So strong electrolyte, they completely dissociate into ions when they dissolve in the solution. Ionic compound containing including the strong acids, strong bases, and salts, the examples of the strong electrolyte. For strong electrolyte, the molar conductivity increases only slightly on dilution. Molar conductivity increases only slightly on dilution, and there is tendency for it to approach a certain limit value when the concentration approaches 0. When the dilution is at infinity, molar conductivity haiendelei kuongezeka tena for strong electrolyte. Conductivity of weak electrolyte. Weak electrolyte, they are substances which ionize partially when dissolved in water. The intensity of its electric current that can pass through the electrolyte depends essentially on the two factors. First is the concentration of ions, and second is the mobility or speed of ions in the solution. Weak electrolyte, they are generally poor conductors of electricity. Why? It's because there are few ions which have been dissociated into the solution. So the limiting factor in a weak electrolyte is the concentration of ions. Weak electrolytes dissociate to a very small extent and give very small or low concentration of ions. The number of ions released in the solution by a weak electrolyte. Number of ions released in the solution by a weak electrolyte is smaller than the amount remain undissociated. Is smaller than the amount remain undissociated. So finally, what happened due to this? Among different weak electrolytes, conductivity varies depending on the degree of dissociation. That is, the molar conductivity of weak electrolyte depends on the degree of dissociation. Molar conductivity and the degree of dissociation, they are directly proportional or directly related. That is to say, molar conductivity conductivity they are proportional to the degree of dissociation. Removing the degree of dissociation, we put the constant K. In 1856, a scientist Arrhenius observed that the degree of dissociation of weak electrolyte increases with increasing dilution of the electrolyte. The degree of dissociation increases as the solution made more dilute. This means that molar conductivity also increases with increase in dilution. Dilution, as we know, is the volume of solution containing 1 mole of solute. So it is denoted as V expressed in liter per mole, or meter cube per mole, or cm cube per mole. Dilution is the reciprocal of molar concentration. Now the degree of dissociation of weak electrolyte increases just to some extent, the point where by however further dilution is made, the degree of dissociation does not increase anymore. When this is reached, the solution is said to be infinitely diluted. Kwa kuna level ambayo solution ikifika, hata kama ukidilute more, the solution will not dissociate more. Kwa tunasema the solution is infinitely diluted. Hiyo solution yetu tunaita kuwa iko infinitely diluted. The molar conductivity of electrolyte, which is measured when the solution is at infinite dilution, is called molar conductivity at infinite dilution, or is called the limiting molar conductivity. Maana yake solution haiwezi ikawa na conductivity kubwa zaidi ya hiyo. Hiyo ndio molar conductivity at infinite dilution, or limiting molar conductivity at infinity dilution. Molar conductivity at infinite dilution is denoted by symbol. Tunaweka symbol, then tunaweka infinity up. So molar conductivity at infinite dilution is constant and does not depend on degree of dissociation. Kwa huyo hapa ni sasa na constant K. Remember we said conductivity molar ni sawa sawa na K, then degree of dissociation. So relating these two equations, we can say from molar conductivity is equal to K, degree of dissociation, then at infinite dilution is equal to K constant. So maana tutakuwa tuna yule pale molar gawanya kwa yule pale at infinite dilution is equal to degree of dissociation of an electrolyte. Kwa hiyo that's how the things they are going, even if ambavyo vitu vinakuwa vinaenda. This is an equation for calculating the degree of dissociation of weak electrolyte. But still we are remembering that the molar conductivity is equal to conductance K divided by concentration C. So substituting this there, we'll be having K divided by C, then conductivity at infinite dilution is equal to degree of dissociation. Hizi ni modification tu mbalimbali za equation zetu. So if electrolytic conductivity, concentration of electrolyte and molar conductivity at infinite dilution are known, then degree of dissociation can be calculated. The graph of molar conductivity against dilution had the following nature. Graph of molar conductivity against dilution. Katika graph huku ni molar conductivity, huku ni dilution. Initially ni kwamba tukiwa tuna graph kama hii hapa, initially huku tuna molar conductivity, tuna dilution. Initially, as we are increasing dilution, the molar conductivity increase. So the increase in dilution is direct proportional to the increase in molar conductivity. But tukifika point inaitwa infinite dilution, there is no increase in molar conductivity. However, will increase dilution. So we are diluting the solution, but there is no increase in conductivity. This is the conductivity at infinity dilution, which is the constant value. And here is at infinity dilution. Infinite dilution actually this point. Hapa ndo infinite dilution. Huku mbele kote tukishapita infinite dilution, the molar conductivity does not increase. So this axis is the molar conductivity. Na huku ni dilution. Dilution is solution yetu, dilution. This is the graph showing the relationship between molar conductivity and dilution. The molar conductivity varies with concentration at constant temperature. Varies with concentration at constant temperature. If the solution becomes diluted, tunakuwa tuna a variation of molar conductivity na concentration at constant temperature. So kwa mfano strong electrolyte variation yake inakuwa hivyo, na weak electrolyte variation yake inakuwa hivyo. I'm not such much sure if here it's dilution or concentration, but yeah, probably this is concentration. I will review this well, and then I will tell you in the next session when we will be discussing about the Kolarski's law of independent migration of ions. Thank you. Tukutane kipindi kijacho.